Hey guys, this is Chapter 10, Section 3 on Newton's first and second laws. So Newton's first law states that an object is going to remain at rest, or if it's moving, it's going to stay moving unless it's acted upon by an unbalanced force. And it's also known as the law of inertia. So inertia is the desire of an object to resist changing what it's already doing. And it does depend on the mass of an object. The greater the mass, the greater the inertia. So the picture up here above, she was able to yank that tablecloth very quickly because those plates and the things on top of the tablecloth wanted to stay doing what they're doing. And as long as she yanked it quick enough, they would remain there. Now, if she tried to do the same thing and there was a big giant boulder sitting on top of the tablecloth wouldn't move out from underneath the boulder because the boulder has too much inertia. Newton's second law of motion says that acceleration depends on net force acting on the object, so the force acting on the object and the object's mass. And you can think of it as our triangle at acceleration, force, and mass. So force is equal to mass times acceleration, or if you're finding out acceleration, it's force divided by mass, and if you're finding out mass, it's force divided by acceleration. So, for instance, if you had this problem, you had a speedboat pulling a 55-kilometer water skier, the skier accelerates at 2.0 meters per second squared and calculate the net force. So you're going to use the formula force equals mass times acceleration. Here is your mass, 55 kilograms. It's been given. Here is your acceleration, which is 2.0 meters per second squared. If you plug in the values, it's going to be 110 kilograms times meters per second squared, which is actually 110 newtons, because you've got to remember that a kilogram times meters per second squared is equal to 1 newton. And that's it.